Hey guys, today we're going to look at quadratic functions. Now, a quadratic function is used a lot to describe paths of projectiles, which a projectile is anything that is either thrown or kicked or hit. So like, think of a football being thrown. The path which it follows models a parabola, which is basically the shape of a quadratic function. Now, several things that we need to know about quadratics. Here we have the standard form of a quadratic equation, the ax squared plus bx plus c. This is what we're most familiar with. A quadratic, just as a reminder, is any function whose largest exponent is 2. Now, if the coefficient a, the one that's attached to the x squared, is positive, then the parabola, which is the shape, will face upwards. If that coefficient is negative, then the parabola will face downward. Additionally, the point right here in the center of the parabola, this is the vertex. And we're going to spend a lot of time today figuring out how to find the vertex of a parabola so that we can graph. Some other parts of a parabola is the axis of symmetry, which is the equation at which the parabola could be folded in half. And it's going to be a vertical line, which you can see here represented on these graphs as that red line. If I were to fold this parabola along the line, this side would land right on top of this side. So that's why it's called the axis of symmetry. And these are always written as the equations of vertical lines, as I mentioned, which are written as x equals and then whatever the number would be. So let's say your vertex, which is always hk, then the axis of symmetry would be x is equal to h. The x-intercepts of a parabola are also called the roots and the zeros of the function, which is where your parabola touches the x-axis. So these here would be the x-intercepts. Additionally, your vertex is also the extrema of the graph, which extrema, as a reminder, is where you have a minimum or a maximum. So for example, here, this would be considered a minimum at the vertex, and this one would be considered a maximum. Now let's kind of break this down a little bit and have a closer look at all of these parts of a parabola. Here we have this function. If I wanted to know what the roots of the function was, we would look at the x-axis and determine the x-intercepts, which are at 0 and x is equal to 2. So we would say that the roots are x is equal to 0 and 2. The equation of the axis of symmetry is where the graph can be folded in half, which would be right here. Remember, it's going to be a vertical line, and it's always written as a vertical line. This would be x is equal, and we look at the x value, which is 1. Now, what kind of extrema does this function have and where? This function, here's my extrema, which is also located at the vertex. So this would have a maximum, since that is the highest point of the parabola, and it is located, and you would give me the coordinate at 1, 1. Now, in order to write the equation of the parabola, which is this final part here, since we know the vertex, we can put it in vertex form, and this is what it looks like. F of x is equal to a times x minus h squared plus k. Now, this should look kind of familiar because it models how we would write functions based on transformations. The vertex tells us how it moved, left or right, because normally any quadratic function would be located at 0, 0. Since the vertex is at 1, 1, that is the h, and that's k. So we can plug in h is equal to 1 and k is equal to 1. The a is determined if there are any kind of dilations or reflections. As you can see, this parabola is facing downward, so there is a reflection along the x-axis, since normally the parabola would face upwards, meaning that a is going to be negative. And as I mentioned in the previous slide, if the parabola faces downward, we already know that a is negative. Now, to figure out if there's a dilation, which we've done this before with transformations, we would compare the vertex point with any other point on the other side, and we look for that distances. The vertical distance from 1 to 2 is 1, and the horizontal distance from 0 to 1, the horizontal distance, either way, they're both 1. And if you remember with parent functions, the distance between the vertex and the next available point is also 1 for the horizontal and 1 for the vertical, so there is no dilation here. So in order to write this equation, we would say f of x is equal to negative x minus 1 squared plus 1. Now let's have a look at how we could graph this function. And I put some steps here that we can follow. So we're going to go ahead and do that. First, we're going to determine whether the parabola opens up or downward, and that's based on A. And this is my A value, which is negative, meaning that my parabola is going to face downward. So that's just, we don't necessarily need to know that information before we graph, but it's a nice way of checking if our graph is correct. Now we're going to determine the vertex, and the vertex is always this value and this value. This is my h and this is my k. Keeping in mind that the vertex form for a quadratic is x minus h. So whatever number is in here for the vertex, we would switch the sign. So my vertex is located at positive 3, 2. So I can already go on my graph and plot that point. Now we're going to create a table of values, and we're going to choose at least 2 points on either side of the vertex. And the reason why we do that is because if you remember, the axis of symmetry occurs at the vertex. So that means that whatever I plot on either side of the vertex is going to be mirrored on the other side. So if we can plot 2 points, let's say on the left, then I can just reflect it along that line on the right side. So that's what we're going to do. We're going to plot 2 points on the left of the vertex. And again, it does not matter if you choose 2 points on the right. The only thing I will say is try to choose points that are closest to the vertex, simply because the farther away from the vertex you get, the bigger the value of y. So it'll be hard to graph if it goes off the graph. So here we go. Let's say I were to choose, since my vertex is located at 3, 2, I am going to choose x is equal to 1 and 2. So I'm choosing that left side. And we're going to plug it in to the function. So we're going to plug it into negative 2, x minus 3 squared plus 2. If I plug in 1, 1 minus 3 is negative 2. Negative 2 squared is a positive 4. And positive 4 times negative 2 is negative 8. Negative 8 plus 2 is 6. Negative 6. Now if I plug in 2, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 plus 2 is 0. So these are my coordinates. 1, negative 6. So we got to go a little bit off the graph here. And 2, 0. And now I'm going to reflect these points on the other side. So since we're over here, we're going to plot this point there, and then this point over here. And then that would be my parabola. We connect, and always connect using a smooth curve. Remember that this has to look kind of like a U. It's not a V like absolute value, it's a U. So make sure that you connect it with a smooth curve. Okay, now in order to find the x and y intercepts, if you graphed it, the x-intercepts, we can just look at where it touches on the x-axis, which would be at x is equal to 2 and 4. Or if you were to solve it algebraically, what we would do is set the function equal to 0 and solve. So I would set negative 2 x minus 3 squared plus 2 equals 0. Now to find the y-intercept of the graph, I can't see it on my graph. That means that it is off of what I have here. So it's obviously going to be somewhere down here if it continues. So I'm going to have to find this one algebraically. And how we do that is by plugging in x is equal to 0. So just to reiterate, if you're finding your x-intercepts, that means that y is equal to 0. And if you're finding your y-intercepts, that means that x is equal to 0. So let's find these y-intercepts. We're going to find f of 0, which is negative 2, 0 minus 3 squared, plus 2. 0 minus 3 is negative 3. And negative 3 squared is 9. Negative 2 times 9 is negative 18, and negative 18 plus 2 is negative 16. So this is my y-intercept. Y is equal to negative 16. Let's try this one more time. We have f of x is equal to x minus 2 squared plus 1. And we're going to graph this quadratic and then figure out the intercepts. So first, I can tell that my quadratic here is going to open upwards. And this is because a is positive. So it should look like this. Now to figure out my vertex. Remembering that this is h and this is k, so my vertex is 2, 1. So I can already go and plot that here. Now I'm going to create a table of values. And I'm going to pick two x values to the left or to the right of the vertex. Because, again, this is my axis of symmetry here at x is equal to 2. And so I'm going to choose the left side just because they're smaller numbers. So I am going to plot 0 and 1. So if I plug in 0, we get 0 minus 2, which is negative 2. Negative 2 squared is a positive 4. And 4 plus 1 is 5. So that's one coordinate. Now we're going to plug in 1. 1 minus 2 is negative 1. Negative 1 squared is a positive 1. And positive 1 plus 1 is 2. So these are my two coordinates, 0, 5 and 1, 2. So now I'm going to reflect that on the other side of my axis of symmetry. And this is my parabola. Now to find the x-intercepts, as you can see, this parabola opens upwards. It's not going to come back down. It's not going to touch that x-axis. So therefore, there are no x-intercepts. In this case, I don't have to actually solve for the y-intercept because I see that it touches the y-axis right here at 0, 5. So my y-intercept is at y is equal to 5. You could also write your intercepts as coordinates. So this would be 0, 5. Now let's see how we can graph a parabola based on the equation if it's written in standard form. And like I said, this is standard form and the one that we're most familiar seeing, which is ax squared plus bx plus c. In order to determine the vertex hk, h is found by calculating negative b over 2a, keeping in mind that b and a is just the coefficients. You do not attach those variables. Once you solve for h, what you do is you take that value and you plug it back into the function. So let's try that out. We have f of x is equal to negative 2x squared plus 4x minus 3. In this particular function, a is equal to negative 2 and b is equal to 4. So if I want to find h, h is negative b, so negative 4, over 2 times a, which is negative 2. Negative 4 divided by negative 4 is a positive 1. So that is my h value for the vertex. To figure out k, we would plug in that h is equal to 1 back into the function. So we're looking for f of 1, which is equal to negative 2 times 1 squared plus 4 times 1 minus 3. Negative 2 times 1 squared is negative 2, plus 4 times 1, which is 4, minus 3. Negative 2 plus 4 is 2, and 2 minus 3 is negative 1. Therefore, my vertex is at 1, negative 1. So when we're graphing quadratics that are in standard form, we follow the exact same steps as earlier, except the only difference is how we locate the vertex. If it's written in vertex form, then we can just pull the vertex from the equation. But if it's not, we're going to have to calculate negative b over 2a for the h, and then plug it in to find k. So here we have negative x squared minus 2x plus 1. This a value is negative, so that means that my parabola is going to open downwards. Let's calculate h for my vertex. That would be negative b, so this negative 2 would become positive 2, over 2 times a, which is negative 1. 2 divided by negative 2 is negative 1. So now to find k, we're going to find f of negative 1, which would be negative 1 squared minus 2 times negative 1 plus 1. Negative 1 squared is a positive 1, but then we have that negative on the outside, so negative 1. Negative 2 times negative 1 is a positive 2 plus 1. These ones here can cancel, and we get a k value of 2. So my vertex is at negative 1, 2. I always like to draw my axis of symmetry so I remember that I'm going to be reflecting. And now you can pick 2 points either to the left or to the right of the axis of symmetry to create your table of values. So let's say I'm going to choose 2 points to the right. That would be 0 and 1. And remember, we're going to plug in those values into the function. If I plug in 0, we get 0 here, plus 1, so 1. If I plug in 1, I would get 1 squared, which is 1, and then negative, so negative 1, minus 2 times 1, which would be minus 2, plus 1. These would cancel out here, so we get a coordinate of 1, negative 2. So I can go ahead and plot my points, 0, 1, and 1, negative 2. And then I can reflect it on the other side as well. And this would be my parabola. Now we're going to practice finding domain and range of these quadratics. The domain of any quadratic, because a quadratic is considered a polynomial function, is always negative infinity to infinity. All parabolas are going to open forever to the left as well as forever to the right, meaning that all x values can be plugged into my function. And since domain represents all of the x values, that would be negative infinity to infinity. Now the range represents all of the y values of the function. So we read our graph from the bottom up. Since this graph is going to go down forever, my range would start at negative infinity. And then the highest y value is located at 2. And the 2, because this is a continuous curve, would be included. So I would put the bracket. And so all of our domains and ranges for quadratics are going to look very similar. The domain will always be negative infinity to infinity, and the range just depends on whether the quadratic opens up or down. If it opens down, then it's from negative infinity to the maximum, and if it opens up, then it's from the minimum to positive infinity, and we're going to see that now. For this one, we have x squared minus 4x minus 1. Because a is a positive 1, that means that my parabola is going to open upwards. Let's figure out the vertex. So we'll start with h, which is negative b, which negative b would be a positive 4, over 2 times a, which is 1. 4 divided by 2 is 2. So h is going to equal to 2. Now, to figure out k, we are going to plug in the 2 back into my function. So we're looking for f of 2. When we plug it in, we get 2 squared, which is 4, minus 4 times 2, which is 8, minus 1. 4 minus 8 is negative 4, and negative 4 minus 1 is negative 5. So this means that my vertex is located at 2, negative 5. So I'm going to go ahead and plot that already. Remembering that this is my axis of symmetry at x is equal to 2. Now we're going to pick 2 points either to the left or to the right of the axis of symmetry. I'm going to choose 2 points on the left, but remember, it does not matter which direction. Since my vertex is at 2, I am going to choose to plot 1 and 0. And we're going to plug in these x values into my function. If I plug in 0, I get 0 minus 1, so negative 1. If I plug in 1, 1 squared is 1, minus 4 times 1, which is negative 4, minus 1. So I have the coordinate 1, comma, negative 4. So I'm going to go ahead and plot those 2 points, 0, negative 1, and 1, negative 4. And now that I have the left side, I can just reflect those points over to the right side. And this is my parabola. Now for the domain and range, like I mentioned, the domain is always negative infinity to infinity, because this is, again, a polynomial function. And the range, the smallest y value is located here at the minimum. So we would say from negative 5, remembering that these values are included, and it goes up forever, so to infinity. Now let's have a look at how we can figure out the minimums and maximums just based on the equation without having to graph. Keeping in mind that if a is greater than 0, meaning that this value here, my parabola is going to open upwards. And since it would open upwards, then this here would be a minimum. If a is less than 0, then my parabola is going to open downwards. And at the vertex, we would have a maximum. So when you're finding your minimums and maximums, the location is the vertex. Okay, so x gives you where on the graph, and the y will give you the actual minimum or maximum value. So let's try to figure out whether this graph is going to have a minimum or a maximum. First, we have to determine whether this parabola is going to open up or down. Because a is positive, that means that my parabola is going to open upwards. And if it's going to open upwards, that means that I have a minimum. Now, in order to figure out what that minimum value is, we're going to have to solve for the vertex. So this we've already done. We have to solve for h first, which is negative b. So negative 16, negative b would be positive 16, over 2 times a, which is 4. 16 divided by 8 is 2. So that's the x value of my vertex. Now to find the actual minimum value, which is k. K, remember, is when we plug in that number back into the function. So we're looking for f of 2, which would equal to 4 times 2 squared, which is 4, minus 16 times 2, which is 32, plus 24. 4 times 4 is 16. 16 minus 32 is equal to negative 16. And negative 16 plus 24 gives me a positive 8. So our minimum occurs at 2, 8. Let's try this one more time. Here we have f of x is equal to negative 3x squared plus 6x minus 13. Determine without graphing whether the function has a minimum or maximum value. Now, since a is negative, that means that my parabola is going to open downwards. And notice that I always kind of draw it out. I'm not graphing it, but I'm drawing it just to give me a visual because it helps me identify this is a maximum. So we are going to have a maximum here. Now we're going to find the minimum or maximum value and where it occurs. So remember, this is the vertex. The actual minimum or maximum value is the y, and where it occurs is the x. So we want to write out the entire vertex. So h is going to equal to negative b, so negative 6 over 2 times negative 3. Negative 6 divided by negative 6 is equal to a positive 1. Now we're going to find k, which is equal to f of 1. So that means that we would have negative 3 times 1 squared is just negative 3, plus 6 times 1, which is 6, minus 13. Negative 3 plus 6 is a positive 3, and 3 minus 13 is negative 10. So we have here a maximum at 1, negative 10. Now to figure out the domain and range, even though we don't have it graphed, it's okay. We can still write it out. We know that the domain, no matter what, is always going to be negative infinity to infinity. Now the range, right, keep in mind, right, if you need a visual, that's okay. This is where y is equal to negative 10 because that's the vertex, right? And we know it's a maximum. My parabola is opening downwards, so that means that my range has to start at negative infinity, and then the highest y value is going to be negative 10, and we would close that with a bracket. So that would be our domain and range. And those are your quadratic functions.